Hello. In this session we're going to look at how to graph sine and cosine waves when there are shifts, or another word for shifts or translations. Okay. Now the process I use, and essentially I'm assuming that you already know how to graph sine and cosine waves, but that what we're really trying to do is figure out how to put together all the different translations, like what's a good set of steps to follow to get it all together. So I'm assuming you do know what the amplitude is, what the phase shift is, what the period is, and what the vertical shift is. So this is all about how to put it together. So the first step is to recognize or label A, B, C, and K, where A is the amplitude, B is going to affect your period, C will affect your phase shift, and K is going to be your vertical shift. Then you find the starting and ending values for one wave by setting bx plus c equal to 0 and bx plus c equal to 2 pi, and then you solve each equation. This is going to give you your beginning and ending values for one wave on the x-axis. And then you're going to label the starting and ending values on the x-axis and divide this distance into fourths using little tick marks, because that's every quarter of the way something big happens with sine and cosine. Next, you're going to draw a new x-axis if there's a vertical shift, which would mean k is not 0. And then you're going to count up and down by the amplitude, the absolute value of the amplitude, from the new axis. And that's where your wave will actually fit. Then you're going to draw in your basic shape around the new axis by drawing big dots to mark what I call the quarter points. It's what's happening every fourth of the way. And if you do have a reflection, which would mean that A is negative, then the basic shape will be upside down. And then finally, you're going to connect the quarter points to make the new wave. And then I calculate the quarter points, the x values of the quarter points, and we'll do that so you can see what's happening each quarter of the way. Okay, so let's take a look at our first example. And our first example will be y equals negative 4 cosine of 2x minus pi over 4 plus 3. Okay, now in labeling A, here's B, here's C, and here's K. So again, this is going to affect your amplitude, this is going to affect your period, this is going to affect your phase shift, and this is going to affect your vertical shift. So now I go ahead and set the bx plus c, which is this part in here, the 2x minus pi over 4, equal to 0 and equal to 2 pi, so I can find where the wave starts and where the wave ends. Okay, so a lot of this is a lot of arithmetic here. I'm going to add pi over 4 to both sides. So now I get 2x equals pi over 4. And here it's just easier to multiply by half. You can think of it as dividing by 2. That's fine. So here's where you'll start, at pi over 8. And I would do the same thing here. So 2x equals, and here the 2 pi I'm going to go ahead and change into a common denominator. So it's going to be 8 pi over 4 plus another pi over 4. So 2x will be 9 pi over 4, and when you multiply by a half, you'll get x equals 9 pi over 8. This is where your wave will end. And of course, I'm saying wave, but this is really just one wave as a pattern for an infinite number of waves. Okay, so we're going to start at pi over 8, end at 9 pi over 8. So what I do then is I have, on my x-axis, I draw an imaginary x-axis here, and I mark pi over 8 and then 9 pi over 8. And what I'm going to do is divide this into fourths, because each fourth of the way something big is going to happen. Now I don't actually have to know these values yet. I just need to have them in there so that when I draw my wave, I know more or less where to draw the points. So from here, I look at my vertical shift, which was 3, and I'm going to have a look at my y-axis. How does that affect my y-axis? So here I'm going to go up 1, 2, 3, and this is my new x-axis. So this is y equals 3. From there, I look at my amplitude, which, let's take a look at that again, is going to be the absolute value of -4, so amplitude is 4. And so I'm going to go up from my new axis, I'm going to go up 4 units. 1, 2, 3, 4, and I'm going to come down 1, 2, 3, 4 units. So I'm going to be all the way up at 3 plus 4 is 7, and 3 minus 4 is a -1. So essentially my wave is going to fit between these two values, between -1 and 7. Now from here, I have to think of the basic shape of cosine. Now I'm assuming that you have seen the basic shapes, sine and cosine, so let me just remind you that the basic shape for any cosine relative to an axis, essentially it starts at a max, then it comes down to the axis, then it goes to a min, comes back to the x-axis, and goes up. And these are the quarter points. So this is what I call the quarter points. This is my first quarter point, my second quarter point, my third quarter point, and then my fourth quarter point. Okay, so that's what I'm going to do here. I'm going to draw the basic shape of a cosine around this axis, going up to the 7 and down to the -1, except that instead of, this is reflected, because remember, this is a -4. So what's going to happen is, here at pi over 8, where I begin the wave, I'm going to go all the way down to -1, because it's a reflected wave. Then the next quarter point is going to go to the axis, then the next quarter point I'm going to go to the max, and then the next quarter point I'm going back to the axis, next quarter point here at the min. Now I join this, or I connect this, so here's the wave. There you go. So there's your basic shape. This is the pattern for all the other waves that you will have for this particular graph. Now at this point, I like to go ahead and say, well, what exactly are the x-coordinate values here? Because those are usually often important when you're kind of going down to 0 or a max or a min. Those are very important. So how do we calculate that? Well, what you have is you have a wave within this distance from pi over 8 to 9 pi over 8. So the distance here is the period. So let's take a look at the distance. 9 pi over 8 minus pi over 8 is 8 pi over 8, or pi. That's my period. Okay? And what I want to do is take this period, or this distance, and divide it into fourths. So I want to take 1/4 of this period. So let's do those calculations. 1/4 of pi is pi over 4. And I want to start adding that. So what I'm going to do is start at the beginning value of pi over 8 and add pi over 4. That's going to give me my first quarter point, what I call the first quarter point. So that's pi over 8 plus 2 pi over 8, and that's going to be 3 pi over 8. And then this is going to be the beginning for the next part. So I'm going to have 3 pi over 8 plus another pi over 4, which of course you know now really you want to add 2 pi over 8, that form. So we have 3 pi over 8 plus another 2 pi over 8 gives me 5 pi over 8. And then 5 pi over 8, this basically comes here, plus let's go ahead and use this form, 2 pi over 8 is going to be 7 pi over 8. And finally, the last one, 7 pi over 8 plus another 2 pi over 8 is 9 pi over 8. And this is a great check because that's our ending value. That's where we should be ending. So that's my first, second, third, and fourth quarter point. So now we're going to use this. Now let's remember these 3/8, 5/8, 7/8, and 9/8. That's going to go here. So essentially what happened is we added pi over 4 to get 3 pi over 8, and added another pi over 4 to get 5 pi over 8, and added another pi over 4 to get 7 pi over 8, and added another pi over 4 to get the 9 pi over 8. So now, I can label these points. This is going to be pi over 8, -1. This point is going to be 3 pi over 8, and 3. This is going to be 5 pi over 8 and up 7. This is going to be 7 pi over 8, and up 3, and finally 9 pi over 8 and negative 1. So this is your basic shape for this particular equation, negative 4x, I'm sorry, negative 4 cosine 2x minus pi over 4 plus 3, that's what y will be. This is your basic shape. And from here, you can think of a little rubber stamp. You just keep stamping it over and over, and you'll get the wave infinitely.